Okay. All right, it's 1 o'clock, so I think we should start. Welcome, everyone. Those of you here at the classroom at Wentworth and those on Zoom. So just a little bit of explanation how we're going to do this before we proceed. So we will do some introduction of the committee members. Matt will be using about 40 to 45 minutes for his presentation. After that, we will have a question session. So people here and on Zoom can ask questions to Matt. After that, we will ask everyone to leave the room so we can have a discussion with Matt, the members of his committee. I don't know how long that will take, but anyway, after that, we can come back to computer. Okay? By the way, after the question session, we're going to end the Zoom meeting because we are recording. Okay? All right, so I think we are ready to go. So I will start by introducing the committee members. So we thank Matt for your patience with us. So we have Dr. Jean-Pierre Michon from the chemistry department. Dr. Terry Hopkins from the aquaculture, Dr. Hermetia. Yeah. And myself, Armando Garcia. Thank you. All right, so I will briefly introduce Matt, say some things about him, and then you can start with your presentation. Is that? Maybe we can start with. Okay. Oh, and then we need to share.
Yes, I think.
Okay. Okay. All right, so Matt is a native here of Hawaii, born in Oahu, and he grew up here in the Big Island. He has an undergraduate degree in agriculture with focus in aquaculture that he got in 2021. During his undergrad time, he collaborated with all of us in the aquaculture program, doing multiple work in research, maintenance of the fish, training of students. So he did all kinds of things, testing ingredients. He was helping also in developing, building new systems, both recirculation, through aquaponics, of course, so he has certificate of that. Collaborating with Adrian, who is also present. So during his undergraduate time in 2019, he conducted and presented an experiment, and he actually presented in a conference, in the Hawaii Conservation Conference in Hawaii. If I remember well, we got honorary mention for that presentation. And actually, his participation in that program, in that conference, renewed his interest in science. Actually, that's how he, I believe, started thinking of joining the graduate program. This year, in the summer, he attended a national fish feed and nutrition workshop at the university in Maine, which is an important meeting. So he is also getting all that experience as nutritionist and aquaculture person too. I'd like to mention this because sometimes we focus too much on academics, but I think especially the people who are working in aquaculture, technical stuff is important. So he's very skilled in using machines and politics. I think in all aquaculture sector, that's very handy. I wish I could have good knowledge, you know, it's very hard to learn all those things along the way, but he already has that knowledge. So he's not only good at getting good grades, he's also good at his skills. They are very, very useful. Of course, he's deeply passionate about his culture and community. Of course, he also likes to work in food production and natural resources conservation and provide. So he's very attached to his land and community. So of course, he's a great person to talk to. Good part of what I know about Hawaii history, culture, and tradition is something that he don't spend under Hawaii, which I very. And just to finalize, he One is recirculating agriculture, animal nutrition, or water quality. We're going in this. Right, without further ado, please, you can start with your presentation. So again, please keep your questions, but also goes into at the end.
Thank you, everyone. I really appreciate that. So thank you everyone for making the time to come and, you know, see me defend my thesis. The title of my thesis, obviously, the use of fermented black soldier fly larvae as a meal, as a replacement for fish meals in juvenile hybrid tilapia. So before I begin, I want to give acknowledgement to this land, especially in the Ahupua'a of KL, where all of this research took place, and especially to my ancestors. They are and were stewards of this land of knowledge and the precious resources which have allowed all people to perpetuate life on these lands. So a quick overview of what I'll be going over. We'll be first going through a brief introduction and background, problem statement. We'll do the research rationale, objectives, the species we chose for this trial, the feeding trial and the research. We'll go through conclusions and implications, and then what I believe to be the next steps for this type of research. And we'll do some questions and answers. So we'll start with a brief introduction and background of aquafeeds and the state of aquaculture, and as it pertains to feed ingredients and fish culture. So global human population growth and the demand for seafood products have concurrently grown over the last few decades. And in 2020, worldwide farm fish production was about 57.5 million metric tons. This is excluding aquatic plants. Aquaculture actually provided for more than half of the world's seafood consumption. And today, worldwide seafood consumption has almost doubled since the 60s, which is kind of, you know, significant. In 2020, the seafood per capita consumption rose from 20 pounds annually to about 40 pounds annually. And over 157 million metric tons of seafood was consumed worldwide. I also want to add that seafood consumption in Hawaii is, you know, as we all know, we love ahi, we love our seafood. So actually, to put this in perspective, in 2019, Hawaiians actually consumed 37 pounds per capita compared to the US mainland, which was actually only 20, so kind of significant. So this figure was obtained from the FAO, or Food and Agriculture Organization, and it shows trends in the world capture fisheries and aquaculture production since the 50s. As you can see highlighted in the red, 2013, aquaculture production actually surpassed capture fisheries production and kind of started trending upwards. And it continues to trend upwards, and the FAO estimates that number to actually be 71% of the world's seafood consumption is going to come from aquaculture by 2030. So throughout the world, especially over the last few decades, world inland aquaculture has been steadily increasing, especially for freshwater production, especially for tilapia culture. In 2020, inland fish culture provided for more than 40% of the global aquaculture production, and 15% of that production, was inland tilapia culture. The growth of inland aquaculture, I mean, not to make any assumptions, but I think it has a lot to do with the potential for using renewable energy. So the lower cost of power basically allows places that would normally not be able to do inland aquaculture to have those advantages. Also, technological advancements in production, animal husbandry and feed. In this picture, you can see that inland aquaculture consists of open pond systems. We have cages. Cages are usually done in like dam areas or areas of like still water. Then you also have tank culture and then recirculating aquaculture. I also want to like add that recirculating aquaculture is kind of a technology that's been more recent, and in this picture right here, this is the National Coldwater Marine Fisheries Center that's in Orono, Maine, and they use a hybrid flow-through recirculating seawater culture system. What they do over there is they raise fingerling salmon to restock the wild fisheries in the Northeast US. So this figure was adopted from Tacone, and it basically shows the simultaneous growth of feed and tilapia culture from 2000, then extrapolated to 2025. What they predict is that in 2025, we're gonna need about 13 million tons of tilapia feed to produce about 8 million tons of tilapia. And actually, after like I did some research looking at these numbers, they're actually pretty well accurate. So traditionally, we use fish meal and fish oil for aquafeeds. Not to say that we don't use other ingredients like seen in the pictures is protein sources like bone and blood meal, also hydrolyzed feather meal, and then meals from proteins like soy seen in this picture. However, there has been this push to kind of get to using vegetable feeds, but a lot of people really don't understand that it's actually pretty unsustainable. You need so much land, so much water to produce small amounts of protein. So we're trying to kind of move away from that, using unsustainable feeds. So this slide basically shows the use of fish meal and fish oil for commercial feeds, like how they used to be pretty broadly available. In the mid-70s, you can see that about less than 10% of the world marine fishery stocks were overfished. About 50% were sustainably fished, and then a little over 30% were underfished. Not even 45 years later, about over 30% is unsustainably overfished. Still 50% is sustainably fished, but as you can see, it's way less than 10% that's actually underfished. So this kind of shows the availability of the resource. This figure kind of goes over the economic availability of the resource. As you can see, in August 2000, the fish meal was $460 per metric ton, and not even a few months later, a few months ago in August 2023, it was over 1,700. This basically corroborates the last slide that shows not only is the resource environmentally, but it's also economically unsustainable. This brings us to the problem statement. Simply, the demand for fish meal and fish oil for aquafeeds continues to rise, but wild fishery stocks can no longer fulfill the need. So what can we do? We could develop the use of alternative proteins and oils to replace fish meal and fish oil in aquafeeds, which is what I studied. Some of the most viable and available proteins come from actually insects, and one of these insects that is very interesting for the industry is that of the black soldier fly. Not only are they sustainable, they're easy to produce with potentially complete nutritional profiles, but they could also be used as a sustainable alternative to fish meal and fish oil. But like anything, obviously there are cons, and one of the biggest cons to rearing soldier fly larvae is it costs a lot to actually produce them. Also, anti-nutritional factors like chitin. Chitin is basically the exoskeleton of the soldier fly larvae. It impedes digestion in most animals, and not to say that it can't be fully taken out of the meal, but it costs a lot to kind of get all of it out. In this picture, you can see on the right, this is the soldier fly meal that we used for the experiment. After it was sieved multiple times, it came really fine and powdery. It kind of had like a cocoa, almost like a cigar smell, and it kind of tasted the same too. I'm just kidding, I didn't try it. You guys are like, oh, you're disgusting. So the fermentation of foods is a practice that humans have used for centuries, basically, and the main reasons that we fermented things was to extend the shelf life and make some of the nutrients more easily digested by the body. Another maybe not so common benefit to fermenting meals is the is the fact that, the crude protein and the crude fat, crude protein can actually increase and crude fat actually decreases when you put it through the fermentation process. So in this, picture, you can see that, the non-fermented meal that we used, was lower in crude protein, higher in crude fat than the fermented meal. And this is one of the kind of the focal points of what Dr. Wei Wen-Su was focusing on. So the rationale behind conducting this research was that insect-based feeds could possibly reduce fish meal and fish oil use in aquafeeds, which could consequently maybe open more options for feed ingredients that possibly decrease feed costs. Also, after doing extensive literature review and a previous feed trial before this one, we understood that we wouldn't be able to achieve a full protein replacement with a single fish meal replacement with a single insect meal. So we would have to formulate the diets with a blend of alternative feed ingredients. So our objectives are pretty straightforward, pretty direct. We wanted to run a feed trial that decreased fish meal by replacing fermented black soldier fly larvae meal in diets for juvenile hybrid tilapia. We would evaluate the effects of the fish meal replacement with the fermented black soldier fly larvae meal on fish growth rates and the feed utilization. Lastly, what we wanted to do was assess the effects of the fermented black soldier fly meal on tilapia whole body composition, and then the final fatty acid composition. The trial was conducted at the UH Hilo Ag Farm in Honolulu. It's south of Hilo, about a mile north of the Pahoa Cal Junction. And then the research was done in 40-foot mountain containers located on the east part of the farm. You can see that in this Google Earth photo right here. So we chose the hybrid Nile blue tilapia cross as a species of interest for many reasons, including their fast growers. They can tolerate high stocking densities, and kind of more of a better one is that they're a large, one of the largest important species in the global aquaculture industry. And I also want to mention that we collected all of these fries all of the fry that we used for this experiment, we collected from the same cohort. So before I get into the trial, I kind of wanted to go over some terms that maybe some of you guys might not be familiar with, so you can kind of understand what we're talking about. But the feed conversion ratio is basically how much the efficiency of the feed to turn fish to turn feed into actual biomass. Specific growth rate is basically what it sounds, how much body weight it put on through the entirety of the experiment. Approximate composition is the percent of moisture, protein, lipid, and ash composed in either the dry feed or the fish. And then retained nitrogen and lipid is the percent of the nutrient retained in the fish flesh from the amount of food that it ate throughout the experiment. Okay, so now to the meat of the presentation. The use of fermented black soldier fly larvae meal to replace fish meal in diets for juvenile hybrid tilapia. I know I kind of went over this already, but I wanted to reiterate the goals of the trial. We wanted to maximize the fermented black soldier fly larvae replacement in the fish diets, and we wanted to analyze growth rates, the feed efficiency, whole body composition, nutrient retention, and fish fatty acid composition. So like I said before, we knew that a full replacement of the fish meal with a fermented black soldier fly larvae was not possible. So what we did is we formulated the trial diet with a blend of alternative feed ingredients. The fish meal came from C-Pro, which is from Pacific Bioproducts in Oregon, located in Oregon. The koji fermented black soldier fly larvae meal came from Dr. Wei Wen-Su from CTAR at UH Manoa. Soy protein concentrate came from Soyco Mill, based in California as well. And then the spirulina powder came from Earthrise, which is also based in California. So what we did is we formulated 4 diets. One was the fish meal 100 control, basically had no replacement, no fermented black soldier fly larvae meal. And then a 10, 25, and 50 fermented meal replacement. And in these pictures, you can kind of see how the composition of each of the ingredients. So this is our formulation table. It's basically the diet formulations and approximate composition of the feed that we use for the trial. So it's displayed in percent dry weight, but basically what you could do is you could move the decimal point 1 point to the right, and that's how many grams we actually put inside the meal. So what we did is for all of the meals what we did is we put a dry mixture together, combined them all, dry mixed it, added water, and then we did a wet extrusion with basically a meat grinder. Extruded onto wax paper and then put it into lem drying racks, basically on a tabletop drying rack. As you can see in the red, the fish meal and the fermented black soldier fly meal, the main protein ingredients that we were testing was incrementally replaced throughout the diet. So I know you guys probably can't do this math in your head right now, but if you can take 23.7 divided by 26.3 is basically 10% replacement, and then all the way up to the 50, right? And then I want to also point out in the dark blue, all of the ingredients are all the same across diets. And I also want to point out, I mean, relatively the same, not far off, but I also want to point out the spirulina and the fish oil were formulated with the same amount of the ingredient. The dextrin, you can see that it's not, but dextrin is more of a binder and really has no nutritional value. So it's basically to bind the ingredients together. The green, you can see that lysine, methionine, and taurine, which are essential amino acids used for growth in fish. They had to be supplemented, but at really, really low rates. So not really significant, but protein composition, dry matter, protein, and lipid were the same across all diets. Protein was 46% and lipid was about 10%. We formulated the diets to have those compositions. So the experimental design was pretty straightforward, and it followed the standard practices for fish feeding research trials like this. What we did was we had 4 treatments and 3 replicates. Basically, what we did was we had 10 fish, each were individually weighed and then randomly placed into 12 separate 90-liter tanks. The abiotic factors like the temperature, lighting, oxygen, and water quality were kept consistent throughout the trial, and fish were fed 2 times a day to apparent satiation. Apparent satiation is basically we fed them until we seen them stop eating, basically. So the trial lasted for 57 days, and at the end of the trial, we took individual wet weights to analyze the weight gain, specific growth rate, and feed conversion ratios. After the feeding trial was complete, we sent triplicate fish samples, three sample sets of feed and fish to the University of Missouri Analytical Labs for proximate amino and fatty acid composition analysis. I also want to add that we use the proximate and fatty acid composition data to calculate the nitrogen and lipid retention for the fish. All of the statistical analysis were done using R. After I met the 3 assumptions of ANOVA, I used the one-way ANOVA to calculate, to see if there were any differences in growth, whole body composition, and feed utilization of the feed. When we found differences, used the 2 P's test to see the differences between treatments, and that alpha P level was less than 5%. Also did a linear regression for the total omega-3 fatty acid correlation between the composition of the diets and the final fish flesh. This alpha level was set at P greater than 5%. So this is what we found. Statistically, there were no differences in the final weight, the specific growth rate or survival, but there were significant differences in the feed conversion ratio. As you can see here, and the insect high, that's 2.8. And actually a higher number of feed conversion ratio actually means that it's actually more inefficient than a lower number. This kind of could be for a number of different reasons, but Mainly it's usually from overfeeding. And then I looked into other studies, that test black soldier fly larvae meal as a replacement for fish meal. And their feed conversion ratios ran about 1.9 to 2.2. So it wasn't like too far off as far as like the insect medium goes. So weight gain was statistically the same across all diets with a P level greater than 5%. Although, as you can see in this table, that the control fed fish showed the highest average growth rate. You can see that bar right in the middle. That is the average weight right there. I also want to point out that the fish that are in this slide, they weren't the biggest fish from each of the treatments, but kind of were like a representation of what the weight gain looked like. Kind of want to put something in there to make it look relatively the same. Lipid and nitrogen retention are indicative of the fish's utilization of the feed ingredients. Basically, the higher the retention levels, the more efficient the animal is at processing the feed ingredients. This bar plot shows whole body lipid and nitrogen retention in the fish fed the 4 separate diets. What we found, although it may look like there are differences, after running it through R, it actually showed that there was no differences. And actually the P value was above 10%, was larger than 10%. I also, if you can see in the plots, the highest level of lipid and nitrogen retention were found in the control diet, which was actually expected. And I also want to note that after I did analyze the data in R, I found no correlation in the fish nutrient retention or the diets. So I wanted to start the discussion section of the trial, kind of with an overview of similar studies that tested soldier fly larvae as a replacement for fish meal, just to kind of like put this our study that we did into relativity. All studies shown in this table replaced black soldier fly meal with fish meal in diets for their respective species, as you can see. Each study found no differences in growth or feed conversion ratio between the fish meal based control diet and the highest replacement diet. Highlighted in the green box, you can see that Aguesu and this study had the closest protein replacement percentage. And I know I kind of like said this in a previous slide that there were no studies that successfully tested 100% fish meal replacement. And that kind of looks contradictory when you see these numbers here. But this kind of gives me a good opportunity to kind of explain this rationale. So some studies can show 100% replacement with fish meal, and that is possible, which also means that there's no fish meal in that diet. So you say 100% of it was replaced, but that means also no fish meal was in the diet. But so that's not to say that there are other proteins in the diet, right? So if you can see here, the 100% replacement, like in Tipiadara's experiment, he replaced 100%, but you can see that only 10% of it was replaced in the diet, meaning only 10% of it dry weight was in the diet. So maybe kind of a little bit confusing, but to recap, there have been not many studies that replaced 100% full replacement of a protein from fish meal with a single alternative meal from fish. I don't know if you guys can get that right now. That's like the most confusing part of this entire thing. So if you got that, we're doing pretty good. So I think we all know that eating fish is beneficial for human health, but this is due to the fact that fish are able to retain long-chain polyunsaturated fatty acids, like omega-3 and omega-6s. And these are really important in the diets for humans, and it's basically why people eat fish, right? The most common source of these omega-3s come from microalgae. Basically what it is bioaccumulated in fish, then in bigger trophic fish, and then to the final user, which is usually humans. What we found in this experiment, which was really interesting, is that fish meal was, as fish meal was replaced with the fermented black soldier fly larvae, there was an actual increase in the omega-3 fatty acids, DHA, and EPA. We also found that there was a negative linear correlation in the total omega-3 fatty acids between the diets and the final fish flesh. And I'm gonna kind of go over that in the next couple of slides to kind of expound upon that finding. So this stat bar graph shows EPA, DHA, and other long-chain polyunsaturated fatty acids in grams per kilogram in the final fish flesh by diets. As a replacement of the fish meal with the fermented black soldier fly increased, EPA, DHA, and other long-chain polyunsaturated fatty acids also increased. When looking at this graph, you kind of might think that there was a positive linear correlation, but after I sent it to R, I actually found that there was no significant correlation. I also want to remind you that most long-chain polyunsaturated fatty acids come from fish oil. And if you remember in the formulations table, that fish oil was the same across all diets. So this was kind of interesting because when we did the fatty acid analysis of the fermented black soldier fly larvae, we found absolutely no EPA or DHA in the meal. So this was kind of something I really wanted to look more into. This figure shows the negative linear correlation of total omega-3 fatty acids between the 4 diets and the final fish flesh. What we found was that as fish meal was replaced, they're going to replace with the fermented black soldier fly larvae, total omega-3 fatty acids increase. And then conversely, you can say that as the fish meal increased, total omega-3 decreased. This was really irregular, and after looking at other studies that tested black soldier fly larvae meal as a replacement for fish meal, we almost all the studies found the opposite. That as fish meal and fish oil was decreased in the diet, also omega-3 fatty acids also decreased. So to kind of conclude, I continue to remind myself, simply explain what did I do and what did I find. So what did I do? I conducted an experiment that incrementally replaced fish meal with fermented black soldier fly larvae in diets formulated for hybrid tilapia, juvenile hybrid tilapia. I tested the effects the replacement protein had on the fish growth, feed utilization, and nutrient retention. What I found was that fish meal can be replaced with fermented black soldier fly larvae up to 50% in diets for juvenile hybrid tilapia without negatively affecting growth, nitrogen and liquid retention, or survival. I also found that replacing fish meal with the fermented black soldier fly larvae at levels above 25% did, however, negatively affect the feed conversion ratio. Furthermore, I found that there was an increase in total omega-3 fatty acid retention in the final fish flesh as fish meal was replaced with the fermented black soldier fly larvae. Lastly, I found that feeding a blend of fermented black soldier fly larvae, soy protein concentrate, and spirulina meals formulated for juvenile hybrid tilapia was possible without negatively affecting the feed conversion or survival. So implications of this study, one of the most surprising results of this study was that of the higher retention of the omega-3 fatty acids in the fish that were fed to higher levels, which was really abnormal considering that fish meal had moderate levels of the omega-3s in the raw material, and the fermented black soldier fly had virtually none. Also, that fish oil was the same across all diets. And I think, I don't want to make an assumption here, but I think the most feasible explanation for this was that the fermented meal from the black soldier fly larvae increased the digestibility or the retention of the fermented black soldier fly. So it might have helped in retaining the omega-3s. I'm not sure, but definitely should look more into it. In 2008, the state of Hawaii developed this sustainability plan, basically that says by the year 2050, I think it is, that we want to be economically and environmentally sustainable and be food secure. I think in order for the state to really reach that goal, the first steps we need to work on is securing our food resources. And a lot of us know that over 90% of the food that we eat is imported from the US mainland. Furthermore, I think one of the bigger reasons why we have issues with environmental problems is because our landfills, for example, our landfills are at capacity. And as our population continues to grow, our resources are being depleted, basically. I think as waste, as a way to remediate this waste, because we really don't have, the state really doesn't have too many plans to remediate it. I think, you could probably kill the proverbial 2 birds with 1 stone with black soldier fly. We could basically grow soldier fly on the landfill waste. We could use the soldier fly to produce protein for an aquaculture industry while simultaneously reducing organic waste that which otherwise would be buried. Although the current cost of the to produce black soldier fly larvae meal is more than double that of fish meal, I think as research and technology, also availability increases, the price should decrease. Also, we can't forget the environmental impacts, mainly taking pressure off the wild fish stocks, allowing our the regeneration of marine fishery food chains. And lastly, when I was researching the soldier fly larvae and producers, I came across this agri-protein, which is funded by the South African government. And they're the largest producers of black soldier fly larvae, but they're not making the insect meal for feeds. They're actually using it to make protein meals to combat human malnutrition in Western and Central Africa. So what do I foresee the next steps of the research to do So what do I see the next steps of this type of research to do? I think it's refining the insect rearing and processing techniques. We know that fermenting protein meals support indigestion as well as increases protein while reducing fat. But there are other fermentation processes that can be used on insect meals. I think those bioprocesses should be evaluated. I think researchers, we also know that the feedstock soldier fly and larvae are reared on affect the overall chemical composition of the final product. I think better understanding these processes and how these substrates affect the final product should be looked into, because we're going to be starting to formulate. I think the industry is going to start to be able to formulate other insect meal based diets for other fish species as well. Refining the processing of the soldier fly meal could also be useful, because the anti-nutritional factors like the chitin, as I said earlier, affect the final product and digestibility. And chitin and the larvae poop actually have been already proven to be a good terrestrial fertilizer. So that's another benefit of rearing them. I think economic and environmental feasibility studies must be conducted. I think if Hawaii plans to be fully sustainable by the year 2050, serious research is needed to realize that goal. Commercial production may or may not be possible here in Hawaii or in other places, but we should do research to find that out. And as my mentor, my dad, and my primary advisor taught me as a young undergraduate, waste and pollution is the result of inefficiency, overfeeding, or over-fertilizing. And we should investigate how to lower and recycle waste streams to potentially use as we develop insect meals for aquafeeds. There's many potential benefits to using insect meals for insect proteins as a replacement for fish meals. We just really have to kind of realize them and implement them, I believe. So I would first like to acknowledge my family, especially my mom and my dad. Thank you for mentoring my fascination with science, pushing me to always ask why. Without you, none of this would be possible, really. Thank you to the Ha'oli Maaloa Foundation for financially supporting me with this 2-year graduate assistant fellowship. To my committee members, the most gracious and humble mahalo, especially you, Armando. You've been a great mentor for me, and I really appreciate all your help. Thank you to Dr. Wei-Wen Su for funding this project. A special thank you to my fiance, Barry Love. Much mahalo to the undergraduate assistants, Justin, Matt, and Nicole. To Jake, the UH farm manager, and Michelle at Packrack, thank you for your support. Tracy and Becky for your academic guidance. Adrian, you've been an invaluable mentor, a friend. I just want to give you my wholehearted mahalo. to the University of Missouri Analytical Labs and Chapel Farms, to my brother, Dr. Christian Dye, for assisting me in building the graphs for this presentation, and all of you have supported me in my journey. Any questions?
Thank you, Matt. Really nice presentation. So we have the floor now open for questions. I will just stop sharing the screen so people in the Zoom meeting can also ask questions. Yes.
First, I want to say, this is a proud moment. Good job and really, anyway, for the research, I didn't follow it as much as I would have liked to, and I found the results really interesting, especially the inverse relationship between food conversion ratio and nutrient retention. I wouldn't expect that. So I would think that this says that filtered by larvae replacement is more about quality than quantity as far as the fatty acids versus weight gains. And I'm just interested if this is not the question, just interested if it can be used for other applications such as salmon. Salmon is a game right with one of our biggest exports and production in that. But I was actually wondering about the water quality. How with this, when you use your control of a regular fish replacement meal, water quality is always an issue with recirculation. So by using a replacement such as black substitution by larvae, I think that would be a big question as to what the water quality the outputs of water quality monitor that, and if that have a positive relationship as well. So I don't know, is it looking for an environment to let this water go into the environment?
I mean, that wasn't like really the focus. Like, we didn't really focus on that part of the the study, but we did take water quality daily. The only issue is that we would flush the tanks every day. We'd flush flush everything out. So the water quality stayed, above what the optimal ranges were. So we weren't necessarily like focusing on that, on water quality, but I mean, I would say that's one of the things that I kind of went over was, environmental and, economical feasibility studies. That's important, obviously, in anything, because I feel like aquaculture gets a bad rap as far as, when we flush systems or the downstream effects of producing animals. But like I said before, all of that is just inefficiency,
That's the reason I asked is that you use theanine and glycine and those could help to be more efficient. And I was just wondering is if that played a factor in this inverse relationship. Maybe there was less weight gain, but could the reason behind that would be seen in water quality is it's not maintaining. It's a fermentation process where some of the additives contribute to.
Yeah, I see what you're saying.
Hence less.
Yeah, definitely. I definitely see what you're saying. They do. I mean, there are ways to collect the feces and then analyze the feces to see how much was actually like uptaken and whatnot. But that's just not something that we focus on. We basically focused on how well the growth rate basically compare fish meal compared to soldier fly meal. The growth rate. Definitely, definitely.
Thank you. Any other questions?
You want to chat?
Yes.
Yeah, I just wanted to be sure I understood talking about the negative correlation with the fatty acids. I thought that it was actually a positive correlation. Can you put that slide up again?
Yeah.
I think we talked about possibly reversing the order so that the percent replacement goes up on the x-axis instead of going down. And then the slope of the line would be positive.
Alright,
That, right?
okay, so if I invert, if I,
Yeah, as it stands, the fish meal 100% has 0% of your wonderful, very carefully chosen replacement. And then left of that is low, then medium, then high. So it's increasing replacement from right to left. If you simply reverse the order,
then it would be a positive linear correlation.
yeah, and I mean, and the axes, see, these are total omega-3s in the diets versus in the fish tissue. And as it goes, as the omega-3s go up in the diet, they go up in the fish tissues, positively correlated. So I think the negative sign is the consequence of having selected the order
Yeah,
of putting things there. So that might mislead a general audience.
yeah,
But except it's done in a scatter. It's not done in the, it's not an order, it's not an order. It's not an order plot, I'm saying it's a scatter plot, it's a scatter plot. So 16% total sustains says total N3 in the diet. So it's 16%. He's in the right place with that.
I mean, what I tried to do was, what I was gonna do was I was gonna take the x-axis and replace it with the, switch the axes.
Oh, no,
But-
I think the axes are correct, because the independent variable is the
Is the
diet
one, yeah.
control. And then the resultant dependent variable is the y-axis. That's appropriate, that's as it should be. That's how minimum squares has to be done. So that's perfectly fine. I'm missing something here, basic, Kevin, because it looks
Well,
like.
like what I'm saying, I'm not worried about what the labels are. I'm just
Right.
looking at the percentage of N in the diet,
Sure.
the bottom, and it's the highest is on the right.
Yeah. Yeah, oh yeah, the scales are fine. The axes are fine. It's simply if you reverse the order of the points.
No, what I'm saying, there's no difference on the order of the point when you're using a scatter plot.
Yeah. I think I understand where JP's getting at. Like, if you were to, like, let's just say, bring the fish meal based diet on the left,
Oh,
and then it would, you would think that,
No,
but it
no.
wouldn't work. Yeah, it wouldn't work like that.
It's not percent.
I see it, let's see. I'm missing something, right, I see your point, the coordinates are the same regardless of the orders, so. What is this telling us as?
Can you flip back to the one before that? That you usually, okay.
This
N3 is omega-3, right?
Hmm.
So the negative correlation means
As fish meal is,
like I just said, right, quality versus quantity, right? So the quality will go down
we would expect to go down.
compared to the fish meal versus the replacement meal.
Even more so too, that the fermented soldier fly larvae had no had little, like virtually none in it, but the fish meal did have. So you would expect it to be correlated in that way, whereas you added fish meal, the omega-3s would go up. Vice versa, if you add the fermented, it would go down, but it wasn't. So, and fish oil was the same throughout all diets too.
I think I would just like to point out there that actually the quality doesn't go down. Because fish meal, the guy has a good quality, actually the quality goes up.
Numbers,
And it's basically the retention too. It's not necessarily, you can give one fish 10 milligrams of whatever amount of omega-3s, and then you can give another one, but it's how they retain it in the flesh. So what I didn't want to make an assumption about this, but what I thought to be the reasoning for that is the way that the meal was fermented, that I was able to retain it differently than as if it was, compared to the fish meal based diets. I'm not sure. I'm not.
I mean, that's the interesting.
It's
part of it.
significant though,
I mean, it seems like there's a biomagnification.
Exactly. Exactly. I'm not sure though. But like, it's really interesting. I would love to like look more into it though.
So the highest replacement, the feed has the lowest amount of the omega-3 acids in it,
Yes,
the tissue has the highest.
yes.
that's being manufactured.
Somehow, yeah, it's being retained by the fish more efficiently, or I'm not sure. I mean,
If it's retained, that would imply that it came in the front door by the diet, which it didn't because the feed is low.
it's still the fish. There's still in the highest diet there it wasn't 100% replaced. It was only there still was 50%, and then fish oil was the same across all diets too. And the omega-3s typically come from fish oil.
So what are we looking at here? EPA, oh, all right, the two long-chain fatty acids that are involved in involved in neural membranes that are crucial, made from like linoleic and linolenic acid. Do fish have the same essential fatty acid humans, linoleic and linolenic, in their diets?
Do they have the same?
Essential nutrients are those that an animal
Can produce on their own.
have to get from their diet. For humans, it's linoleic and linolenic.
I believe, I'm not exactly sure, I'm not sure,
Those are essential for fish.
Right, okay, that I'm answering. And I wonder also the amino acid set that are essential for humans, meaning we can't make enough of them or at all. So we have to get them from diet, essential in diet. Is that the same set for fish?
Yeah.
Oh, wow. Great. Can you go back to the graphic that does,
the correlation.
the scatter plot. Yeah, I see them in clarified, but those are just the data, the scatter plots. So that's omega-3 in the diet, and it's lowest for the highest replacement, 14.8 or 14.7-ish in the highest replacement diet. So it's lowest in the diet, but highest in the tissue. That's a marvelous result. And there must be a way to present that.
Yeah, present it.
A casual reader or
Yeah, present it a little bit better. I see what,
a weight reader like me
yeah,
sees that it's a good thing.
yeah,
It is, right? I mean, it looks really exciting.
yeah, it looks good when, yeah,
Wonderful result.
I mean,
That's how you state linear correlation in South States. There's definitely a trend going on here, something going on.
yeah.
We're investigating.
I mean, I could definitely look, I kind of just, I don't want to like lie, but I kind of just threw this together for the presentation. I mean, but I'm sure I could, if I could use a little bit more time and I could make it in a more, like a positive way, because when people think of like negative for, they're like, oh, that's bad, like when necessarily it's not, but.
Well, another way, I guess, instead of putting the omega-3s in the experimental diet on the abscissa on the x-axis, as it's often called, if you just put the amount of replacement, fish meal replacement, so for the control, for fish meal.
Oh, I see what you're saying, yeah.
For the low, it's 12%, 30%. Medium is a higher percent, and the high is a higher percent. So if you put percent replacement on the x-axis, on the abscissa, then on the ordinate or y-axis, then it would go up, and people could see.
Yeah,
This is an exciting result. It's
Gotcha.
impressive, and we don't understand the biochemistry, but it bears looking into. Good for finding that. That's exciting.
Definitely though. I think I'll look into doing that with, as far as putting percentages on
Leave
the,
this as it is, but as David said, it's the data is important. And Armando did a great job on that. But if you could do a similar graph where you had percent replacement on the x-axis from 0, which would be the control, low, medium, high, then the trend would be
you
up.
see the trend going in the positive,
See at a glance that with greater replacement of your special diet, be very carefully prepared. If you're getting more ideal, the fatty acids you want, the omega-3s in your fish blend.
I'll definitely do that.
Great result.
Yeah, I'll definitely do that. That makes actually makes more sense to do it that way, to tell you the
So this
truth.
is important, but the other way also clarified.
Did you do your analysis? Do you have replicates? Did you have 3 replicates at each one of these levels?
Yeah, I did. They were all I collated, like I put them all,
But on the graph, it would be better to show
multiple points.
So you see the scatter.
Okay.
Yeah, you could either do just the basic points, the raw data, which a lot of people prefer, or at least some sort of error bar. A lot of error bars are frustrating them because sometimes the standard error of the mean is. Yeah, that.
So just, yeah, I got you.
95% confidence interval is huge.
Instead of averaging them all together, make the whole scatter plot.
Yeah,
Yeah,
yeah, that's a great idea, I like that.
put all the points, yeah.
Yeah, but that's an exciting result. That's great. It's gonna decrease your R squared, but that's fine.
Yeah.
Thank you, Matt. Do we have further questions?
Matt,
Yeah.
Matt, Matt, this is your brother.
Wait, hang on, 1 second.
Over there. Okay.
um, can you hear me?
Yeah, got you.
Well, congratulations, Matt. Wonderful talk. Great research. It's good to see the growth you've had in these last few years just doing this. I'm very excited to see like your next steps in your career. If they were as impactful as these 2 years have been, you're going to do some amazing things. My question is more like a general question. I think, you know, this is kind of one of those rite of passage questions. If you had all the money in the world, all the resources in the world, what would be your next steps in your research? And maybe in the next 10 years, where do you see this going in the next 10, 20 years? I know you kind of hinted on it in your discussion, but can you kind of explain what you would do if you had unlimited funds?
Personally, well, I think, you know, I am very, you know, I love this land, I love this island so much that, and I see the potential to grow industry here. You know, we have so much land, we have so much water resources, and we have so many people that are dependent upon getting food from the mainland, and it's not you know, that's not security by any form. And I think what I would want to do is build industry here. You know, like, to feed yourself is that, to me, that is true independence. Like, if you cannot feed yourself, you will never really be free, you know, and you're living in this. To me, that's the scariest thing that could be possibly for a human to go through, is being scared of where their next meal is coming from. And to me, there's a lot of people on this land that deserve not to be living in that kind of fear. And for me, if I had all the money in the world, mats and containers wouldn't be coming in here anymore, basically.
Okay, great. And I have one last follow-up question. So, you know, this is great for Hawaii because we don't care what kind of fish we eat. We love them all. But, you know, if you wanted to go to, say, the mainland, California, Oregon, you know, popularizing tilapia is not going to be the greatest option. Do you think this could be applied to, say, other fish like salmon, things that are more in line with less, like...
I don't know if you remember the slide that I had on here before, but they actually soldier fly larvae, the first animals that they tested insect meals for were actually for salmon eggs. They, you know, tilapia wasn't the first one. You know, tilapia wasn't the first ones. Actually, it was salmons that they you know, started testing on first. So, I mean, obviously salmon is like you know, it's a high value crop. Tilapia, not so much, but you can grow tilapia virtually anywhere. And I know, like, you living in New York, it's hard to get access to you know, fresh fish, salmon, whatnot. And if you do, it's expensive, right? Tilapia still tastes good and it's cheaper. You know what I mean? So to me, it's like, so I mean, you know, tilapia gets a bad rap, I feel like, but you can, it tastes good. You can make it taste however you want, you know. Salmon, granted, you know, if everyone can eat salmon all the time, great, but that's not sustainable, you know.
A lot more tilapia is produced in the world than salmon.
Yeah, exactly.
Millions or more tons of
Yeah.
tilapia produced.
Yeah.
And I think it's.
Thanks for your question.
It's a good question.
The white salmon.
Pigs and chickens.
One of the arguments I've heard, maybe people correct me if this is wrong, is the argument for cold water fish is that it gives you a better fatty acid profile.
Mhm.
But what your results are showing seems pretty clearly is that with a warm water fish, you're getting high levels of the desirable
Yeah.
omega-3 fatty acids that are really important for maintaining neural
Mhm.
membranes and actually implicated in dementia, which I'm probably getting now. Oh, by the way, can we let him graduate with a fish fry?
I swear, I was gonna, I wanted this, I saved maybe like six of them, but they're tiny. It'd be like a couple chips.
No, but that's really exciting. And,
Yeah, it's
you
cool.
know, I think that would be worth a publication of its own.
Yeah, I mean, there was only, I went through about 26 studies, and only three of them had even a close to that. But all of them were not unfermented, like our study was specifically using fermented black soldier fly larvae as the replacement.
Many people use the koji fermentation, or there a wide variety.
I'm not sure. I mean, see, that's the problem, is we didn't really so the Dr. Su, he was the one who, you know, was kind of like, you know, doing that side of the research. So we just would be basically taking his, you know, product and testing it on the animal. So I'm not too sure, but we definitely are gonna, but we can find out.
I think people are just trying different ways to process this meal to make it better. Because I've not mentioned, fat content very high, but that fat is not a type.
Right.
So they want to review it by fermentation and other process. So that's the main reason behind all this. So these professors spend different processes to review it, that originally, and then at night they invest it.
I dangerously fell into a Wikipedia walk before the talk today, and was finding that I guess it's a dinoflagellate that's used largely by the egg industry to produce, I think, one of the precursors or the actual long chain fatty acid in -3, one of the F. Anyway, one of the two that are important in neural membrane function. I don't think that primary use was necessarily going for aquaculture feed, but it seems like if there already is a large agricultural production of that, you might want to tap into that.
Yeah,
Hilo has a lot of skills in that area.
yeah, for sure.
Amazing guy.
For sure.
Any more questions?
Anybody?
All right. If no more questions, we thank you again for this.
Thank you, guys.